Hello, and welcome back to the race. We're going to watch the points A, B, and C race around their respective curves, using the assumption that theta increases at a uniform rate from 0 to 360 degrees. We will see that sometimes the ellipse is behind and sometimes ahead. Let's take a closer look using the slopes of lines. Last time we agreed that the slope of the radius of any point for the two circles is the tangent of theta, whereas the slope for the radius of any point on the ellipse is 3/4 tangent of theta. Also, we noted that the slope with the greatest absolute value is the steepest, and the line with the steep slope is closest to the y-axis, and the line with the shallow slope is close to the x-axis. That's what we're going to use in this video. So we start out when theta equals 0, everyone has an equal footing on the positive x-axis. In the first quadrant, the circles are running ahead. When we get to the y-axis, of course, tangent is undefined. Fortunately, GeoGebra does not throw an error, but just gives us question marks. Anyway, they're all tied up at the y-axis. And then in the second quadrant, the ellipse gets ahead because the absolute value of the slope of the radius of the circle is higher, so that radius is steeper and closer to the y-axis. So now we're headed for the x-axis, and the point B is ahead. Tied up again, circles are ahead, tied up again, ellipse is ahead. And they all finish at the same time at the end of the race. So starting in the upper right, we can see that A is always closer to the y-axis, so it's ahead. When we come to the second quadrant, the next stop is going to be on the x-axis, so B is ahead, and so on. What we can see from this is since theta is moving at a constant rate, the angle swept out by the points on the circles is always constant. Since the angle swept out by the point on the ellipse is sometimes behind and sometimes ahead, it must not be constant. We don't know what its value is, but we know it's not constant. Let's have a closer look next time. Thanks for watching. See you next time.